employees, and by the third month there are 10 employees. The CEO keeps hiring according to this pattern.
Okay. So in the first month, we have 4 employees. In the second month, we have 7. And in the third month, there are 10. So let's put a 10 right here. Adding what? Adding 3. Good job, bud.
So 13.
Plus 3. Plus 3. So we're adding 3 each month. Watch out for that because the next month is, so in the fourth month, we have 13 employees. But do you see what it does over here? It's trying to trick you. It skips a month. So this is 2 months. So how many employees are we adding each month? So we're really adding 6. 13 plus 6 is 19. Okay. And then I go from month 6 to month 11. So how many months have passed? Plus 5 times 3. Do you guys see that? So 15 plus 19 is, good job. I'm going to write it out. So month 6, month 7, month 8, month 9, month 10, and month 11, just because some of you guys might need to see this. So in month 6, we had 19 people. We're adding 3 each month. So that would put me at 22. Adding 3 each month. That would put me at 25. Adding 3 each month. That would put me at 28. Adding 3 each month. That would put me at 31. Adding 3. That would put me at 34. Notice that what we're adding each month became my multiplier right here. Right? Because this is an arithmetic sequence. This is an arithmetic sequence. We're adding or subtracting the same amount each period. Okay? So how does the number of employees grow from month to month? What are we adding or subtracting each month?
3.
So 3 more employees are hired each month. So that means my common difference equals what? I'm going to abbreviate that. Common difference equals what? What are we adding or subtracting? Owen. Yeah, your common difference would be 3. Okay. So it says plot the number of employees in each month on the graph below. What do you notice? Well, we know in month 1 we had 3, in 4. In month 2 we had 7. Month 3 we had 10. Month 4 we had 13. Notice your graph y-axis is counting by 5, so you're just going to have to kind of ballpark it. You're going to have to eyeball it. In month 5, we had 13 plus 5, or plus 3 is 16. In month 6, we had 19. In month 7, we had 22. In month 8, we had 25. In month 9, we had 28. In month 10, we had 31. And in month 11, we had 34. So what do you know about that graph? What does it look like? Say it, Avery. That's okay. Look at your journal. Not even using any fancy words. What does that graph look like? If you just look at it quickly, it looks like it's making a what? A diagonal? Didn't I say diagonal? Yeah, okay. Yeah. What is that? A line? It looks like it makes a line. Just say it. It looks like it makes a line. The only difference is it is a That's that word you couldn't think of. Discrete linear function. It's still linear, but we don't connect it with a line because our inputs, remember, are whole numbers. 1, 2, 3, 4, 5. That's what makes a sequence unique, right? We can't connect the middle pieces. It's just got to stay dots. Assuming this pattern were to continue, how many employees will there be after 2 years? That's 24 months. Sounds like we might need to write an explicit formula. Sounds like we might need to write an explicit formula. So you might need to look at your journal from yesterday and tell me how to do that. You got it? Oh, don't tell me the answer yet. Let's write the formula first, and then I'll call on you for the answer. No, not yet. I want the formula first.
AN equals A1.
So AN equals A sub 1. What is the first term? How many employees did we have in month 1?
4.
4 plus, what is our common difference? 3 times N minus 1. All right, now you can tell me what you did. What'd you get? Okay, I didn't get 74. I got 73. So, well, that's why you got to write a formula. So we're trying to figure out 24 months. 24 months. 2 years is 24 months. So 4 plus 3 times, what is going to be in the N minus 1 parenthesis? 23. Okay, let's see. So 3 times 23 is 69. 69 plus 4 is, so in the 24th month, there will be 73 employees. Can you write a rule that will give the number of employees after n months? Well, we already did that. That's what this explicit formula is. So we're just going to rewrite it. A sub n equals 4 plus 3 times n minus 1. This is the explicit formula. Explicit formula. Does that make sense? I'll give you a copy of this when we're done. There should be one more copy that you can grab since you don't have your packet, but I'll just make a copy of these. Okay, so let's fill out the quick notes and then we're going to be done. We're going to fill out the quick notes. We'll do this check your understanding tomorrow. So let's just fill out this box because I think that you guys are going to tell me what you notice. So what have you noticed from what we did today, applications of sequences, because this is really an application of an arithmetic sequence. What we did by looking at the table and then the graph and determining what's happening to X is a type of sequence. So what are some things that you know? How do you identify an arithmetic sequence? If you just looked at a list of numbers, how would you know if it was arithmetic? What do you mean they're the same? If you just saw a list of numbers, let's see, 5, 11, 17, 23. Is this arithmetic? How do you know, Owen?
Because the numbers continuously add by 6.
Yes, so we know that an arithmetic sequence, what's that called when we change it continuously? What's that word that we change it by continuously called? A common difference. Okay, there you go. So arithmetic sequences have a common difference. That's one thing that we know. Okay, has a common difference. What rule did we use to write today? What kind of rule can we write with an arithmetic sequence? Yeah, what's that called? Thank you so much, Ms. Spanko.
Explicit.
Explicit. What is the explicit formula?
AN equals A1 plus D parentheses and minus 1.
Okay. So if we're writing an explicit rule, what is A sub 1 representing? A sub 1 is the what? Anyone? Just shout it out.
The first y value.
It's the first term.
First term.
Yeah, it could be a y value, but we don't know about this. It just could be a term in a sequence. Okay. What does D represent? So what's that called? The common difference. Okay. Do we know any other rules? Okay. That's what I want to talk about. So what we discovered today is what happens to X is when you multiply, and I'm going to abbreviate that, or divide that number that you multiply or divide by is slope and what you add or subtract is the y-intercept. That's huge. What you add or subtract is the y-intercept. Remember that the y-intercept is the ordered pair 0, comma, some number. So if you have an input, an x value of 0, you always know what the y-intercept is because it's whatever the output is. When x is 0, your output is your y-intercept. How do we feel about that?
Good.
Good? Okay. We'll finish 1, 2, and 3 tomorrow. Your guys' homework is pages 5